Hi, my name is Brendan Bohan, and I am a Solutions Engineer here at SingleStore. Today we are going to explore hybrid search in SingleStore, which marks the ending of our series, Search Tactics in SingleStore. In this final part, we will string together everything we've learned and put it into practice. This implementation will showcase a ton of SingleStore capabilities, as we are utilizing pipelines, indexes, and the combination of full text and semantic search. In our previous videos, we went over semantic search and vector search, which are integral components of SingleStore's hybrid search capabilities. They allow for enhanced information retrieval by blending full text and vector indexing methods. SingleStore's hybrid search combines these techniques in a single query, leveraging the strengths of both to produce more accurate results. By creating subqueries for vector and keyword searches and re-ranking the combined results based on their scores, developers can achieve powerful search solutions that effectively understand both semantic meaning and keyword relevance, ultimately providing deeper insights from the data. A massive issue in AI applications today are hallucinations. While these are hard to prevent because of limited data, contradicting data, or even too much data, hybrid search is a crucial step in improving overall accuracy. Okay, let's get to it. As always, you're going to want to navigate to the Data Studio on the left. And here there are two ways you can follow along: create a new blank notebook or import the notebook from the description. I'm going to import from a file on my local system. Click the Hybrid Search Tactic notebook, then click Import. Now that it is imported, let's run through it. To start, as usual, we're going to want to create a quick test table. We are going to be importing some text data from an S3 bucket, so we will declare the column types, making sure to include the vector data type. Next, we'll set up a pipeline. This is a sample S3 pipeline in SingleStore that is open, so we don't need any credentials, luckily. For more information, you can check out our Running Pipelines in SingleStore video, linked at the top right of this video. That will get you a better understanding of pipelines if you are unfamiliar with them. I'll explain this pipeline in a bit more detail. The data that is stored in the S3 bucket contains an ID for each entry, the URL for the Wikipedia page, a small summarizing paragraph of that Wikipedia page, and finally, the embeddings of that page. Having such a large data set, using real-world scraped websites along with their embeddings will show just how fast and accurate hybrid search can be. And you can see, within seconds, close to 40,000 rows were ingested. Now, since we have the data loaded in, we can start searching upon it and extracting meaning. Before we do that, it's important to add the proper indexes to each column. One full text index and a vector index. We're going to use IVF flat for today, but as always, you can use other indexes such as HNSW or even HNSW PQ. Of course, to make sure all the values above are indexed, we will go ahead and run the optimize command. I'm a huge fan of Mario Kart, so I'm going to try and search for my favorite game. But I'm not going to just search for the Mario Kart keyword. I'm going to set the search vector as the embedding that is attached to the Mario Kart object pulled in earlier from the S3 bucket. Once that is set, we can start utilizing hybrid search. This SQL command is using common table expressions to first find a full text match and then find the vector similarity match. Finally, we are going to select and format the data from both CTEs. We then weigh the two and combine them for their average total score, making sure to get all results from both tables. And there you have it. The top 5 results for Mario Kart based off of both its embedding similarity and textual relevance. Get creative, and as always, if you have any questions, feel free to speak with the team.